Okay, this is now fractions review. In this first question, we have to change the improper fraction, 14 over 5, to a mixed fraction. Now, the reason that 14 over 5 is called an improper fraction is that the numerator, which is 14, is larger than the denominator, which is 5. Now, to express an improper fraction as a mixed numeral, what we do, we divide the numerator by the denominator to obtain the whole number part, and then we write the remainder over the denominator. Now, 14 over 5 really means 14 divided by 5. So what we're really doing, we're saying how many times does 5 go into 14? So 5 goes into 14 2 times because 5 times 2 is 10, and there is 4 remainder over 5. So the other way we can look at this, our mixed fraction answer is 2 4/5. The other thing you can think of, if you're thinking of pizzas, for example, is that each pizza is cut into 5 pieces. In the first pizza, we have 5 pieces. In the second pizza, we have 5 pieces. And in the third pizza, so I'm just going to draw those all up. So first pizza is cut into 5. Second pizza is cut into 5. So we've got 5, we've got 10. The third pizza is also cut into 5, but only 4 of them are shaded. So that gives us 14 fifths. Okay, so each circle is cut into fifths, and we've got 5, 10, 11, 12, 13, 14 fifths. So that is the same as having 2 whole circles or 2 full pizzas and 4 fifths. Okay, so you can do it by dividing. 14 over 5 is 14 divided by 5, which is 2 4/5, or you can do it by drawing out 14 fifths as I have in the diagram below. Okay, you can try the question over here, change 10 over 3 to a mixed fraction. Okay, now 10 over 3 means 10 divided by 3. So we want to see how many times 3 goes into 10. And if we do our times tables or count up by 3s, we've got 3, 6, 9. So 3 3s are 9, and then we've got 1 remainder over 3. Alternatively, you can say, right, each of my circles is cut into thirds. We know they're cut into thirds because the denominator is 3. So to have 10 thirds, I'd have to shade 1 full circle, 2 full circles, 3 full circles, and 1 extra piece. So that gives me 3, 6, 9 pieces, and 1 extra piece, that's 3 1/3. Okay, so we've got 3 full circles and 1/3 here that's shaded, 1 out of 3. Now, in the next question, we're actually doing the reverse of what we've done up here. So we're actually expressing this mixed numeral. Now, this is a mixed numeral because it's got a whole number part and a fraction part. So it's called a mixed numeral, and we have to change it to an improper fraction. Now, we've really got 3 2/5. So first I'll do it by the method mentioned here, where we multiply this whole number part by the denominator. So what we do 3 times 5 is 15, and then we add on the numerator part of the fraction. So we go 3 times 5 plus 2, is 15 plus 2 is 17, and then we end up putting that over the total. So what we've got is that 3 2/5 is 17 fifths. That's doing it this method over here. The other way of doing it is to look at what 3 2/5 means, and it means that you've got 3 full circles and 2/5 of a circle. So this last circle is cut into 5s, and actually all the other circles will be cut into 5s as well. Because when you see a fraction and you've got fifths, it means that everything has to be in terms of fifths. So what I've got is 1 whole circle, 2 whole circles, 3 whole circles, and there's 5 parts in each, which is why we've got 5 parts, 5 parts, 5 parts. And here I've got 2 parts shaded out of 5. So what I've really got is 5, 10, 15, 17 parts shaded, and they're all fifths. So my answer is 17 over 5. And that's how we change that improper fraction how we change that mixed numeral to an improper fraction. Okay? Well, as I said, we've got 5 out of 5 shaded here, 5 out of 5 there, 5 out of 5 there, and 2/5 here. Okay, you can pause the video and try this question over here to change 4 1/3 to an improper fraction. Okay, if we use the method over here, we've really got 4 circles and they're cut into thirds. So that's why we do the 4 times 3, which is 12. So we've got 12 parts there, and then we add one more part and we get 13. So therefore 4 and a third is 13 over 3. The other way of doing this question is to draw it, where I've got 4 full circles and my last circle over there. Each of these 4 full circles is cut into 3s. Actually, all the circles are cut into 3s. I've got 4 full circles, and in my last circle I've got 1 shaded piece. So I've got 3 pieces there, 3, 3, 3, and 1 more piece. So I've got 3, 6, 9, 12, 13 pieces, and they're all thirds. So therefore my answer is 13 over 3, which is what we got here. Okay, so same answer. All right, but just doing this using diagrams. Okay, now in this next question, we're finding the highest common factor of 8 and 12. Now the method for this is listed over here, to list all the factors of the first number and list all the factors of the second number, and then find the highest factor which is common to both of these numbers. So when you look at highest common factor, what you should do is do it backwards. You find the factors first, then you see which ones are in common, and then you work out which one is the highest of those common factors. So let's look at the factors of 8, and we're going to look at the factors of 12. Now we know that 1 times 8 is 8, so therefore 1 and 8 are factors of 8. We also know that 2 goes into 8. Okay, so 2 times what is 8? It's 2 times 4 is 8. Now, so what you should do when you realize that 1 is a factor, you should put its partner, which is 8. If 2 is a factor, then put its partner, which is 4. And you should do 1 over there, 8 over here, 2 there, 4 there. Now we know that 3 doesn't go into 8. We've got 4. 5 doesn't go into 8. Neither does 6 nor 7. So we've listed all the factors of 8 there. Now we have to do the factors of 12. So again, 1 goes into 12, so 12 times. So 1 times 12 is 12. Again, 12 is an even number, so 2 will go into 12. And 2 times what is 12? It's 2 times 6. So as I said, if you find one factor, find its partner and write it down straight away. It'll make the job a lot quicker. 2 and 6 are partners. Does 3 go into 12? Yes, it does. And 3 times 4 is 12. So our remaining factors there are 3 and 4. Now 5 does not go into 12. We've got 6. 7 does not. 8 doesn't. 9, 10 or 11 do not. So therefore we've listed all the factors of 12. So therefore we've done the first step, which is to list all the factors first. And we've done the factors of both numbers. So we've done the factors of both. Now we do the second letter here, which is common. Now which factors are in common? Now we know that 1 is in common, 2 is in common, and 4 is in common. But which one of those is the highest of the common factors? And it's 4. So therefore the highest common factor is 4. Okay, you can pause the video now and try the question over here, which is to find the highest common factor of 12 and 20. Okay, hopefully you would have done the factors of 12. We start with 1 and its partner is 12. We know that 2 goes into 12 and its partner is 6. 3 goes into 12 and 3 times 4 is 12. So its partner is 4. We know that 5 doesn't go in there, neither does 7, 8, 9, 10 or 11. So they're the factors of 12. Now we need to list the factors of 20. Again, we've got 1 and its partner is 20. So 1 times 20 is 20. We've got 2. 2 times what is 20? It's 2 times 10. So 10 is another factor. Now, 3 does not go into 20. Okay. 4 goes into 20. And 4 times what is 20? It's 4 times 5. Okay, 6 does not go into 20. 7 doesn't. 8 doesn't. 9 doesn't. 10 doesn't. And all the numbers from, just think if 10 doesn't, then anything else between 10 and 20 won't, because from 11 to 19, none of those numbers will go into 20. So therefore we've done the first step where we've listed the factors of 12 and the factors of 20. So we've done the F first. Now we look for the common factors next. Now, which ones are in common? There's a 12 here, but not here. There's a 6 here, there's no 6 there. There is a 4 there and here. And there are 2 in both of them and 1 in both, but again, the highest common factor is 4. Okay? Okay, now to find the lowest common multiple of 2 numbers. This question is asking to find the lowest common multiple of 4 and 6. Again, you look at it backwards. You write the multiples of both numbers, then you see which multiples are in common, and then you look for the smallest one. So our method is to list the multiples of the first number, and then the multiples of the second number, and then find the lowest common multiple which is common to both these numbers. So I'm going to list the multiples of 4. Now multiples is like you do, it's like you can think of multiplication tables. So it's like doing your times tables. So basically it's 4 times 1 is 4. 4 times 2 is 8. Or you're just doing multiples of 4. So you keep adding 4 on every time. So if we keep adding 4, we've got 4, 8, 8 plus 4 is 12, 12 plus 4 is 16, 16 plus 4 is 20, 20 plus 4 is 24, and I'm just going to put some of those. I'll just see if that's enough. I'm going to do now the multiples of 6. So counting up by 6s, we've got 6, 12, 18, 24, and I'll just stop there. Okay, so there I'm counting up by 6, or these really are my 6 times tables. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and I'll just stop there because we've already got a number of multiples that are in common. Now, we've got 4 is here, but it's not there. 8 is here, but it's not there. 12 is common to both. I mean, there are other factors that are common. 24 is common, but it's not the lowest of those common factors. So therefore, the lowest, of those multiples. So therefore, the lowest common multiple to both the numbers 4 and 6 is 12. So the lowest common multiple is 12. Okay, please pause the video and attempt this question here. Find the lowest common multiple of 3 and 8. Okay, following the first step, we list the multiples of 3. So we just keep adding 3. 3, 6, 9, 12, 15, 18, 21, 24. I think I'll stop there. Okay, and the multiples of 8 are 8, 16, 24, 32, and I'm going to stop there because I've found one that's in common. Now let's look at the first row here. We've got 3, 6, 9, 12, 15, 18, 21, 24 is the first one that is in common between those 2 rows of numbers, and it's also the lowest one because it's the first one that occurs. So therefore the lowest common multiple of 3 and 8 is 24. Now for the next page in your fractions revision. Here we are wanting to complete the equivalent fractions. Now, the rule to find equivalent fractions, you either multiply or divide both the numerator and the denominator by the same number. So we're saying 3/5 or 3 over 5 is equal to something over 20. Now, because 3 is on the numerator and I don't know what this other numerator here is, then we work with the denominator because I've got a complete pair here. I've got 5 and 20. And I say, well, how do I go from 5 to 20? You either have to multiply or divide to get from one number to the next. Now, the way we would go from 5 to 20, because we're going bigger, we would have to times it by something. So 5 times what is 20, and it's 5 times 4. So therefore, you must do the same thing to the numerator. So therefore, 5 times 4 is 20. So we say 3 times 4 is 12, okay? So in these equivalent fractions, we've gone from 3/5 to 12/20, and so the fraction, the numerator and the denominator have both become larger. Now in this question down here, I'm just going to put a little line to divide, to separate. Okay, sorry, I had to pause the video and restart it. So we say, how do we go from 15 to 3? So to go from 15 to 3, we would divide by 5. So therefore we divide the denominator by 5. And 25 divided by 5 is 5. So therefore 15 over 25 is equal to 3/5. Notice we did that by dividing both the numerator and the denominator by 5. If you could pause the video and try these two questions over there. Okay, so our complete set here is the 2 and the 6, and we say, well, how do we go from 2 to 6? It's getting bigger, so you must have to multiply the 2 by some number. So 2 times 3 is 6, so we do the same thing to the denominator. 7 times 3 is 21. So notice whatever you do to the numerator, you must do to the denominator. In the next question, we're looking at how we go from 28 to 4. Now 28, making 28 go down to 4, we're obviously making it smaller, so you would divide. And looking at your times tables, 4 times 7 is 28, so to go from 28 to 4, it's 28 divided by 7 is 4, so you therefore divide the numerator by 7 as well, and 21 divided by 7 is 3/4. And so 21 over 28 is equal to 3/4. Okay, now we're asked to simplify 6 over 15. Now another way that this question can be asked is that they can say reduce this fraction to its lowest terms. Now it's very, when you do this question, it's really like finding equivalent fractions, but you won't be multiplying at all. To simplify it and to reduce it to its lowest terms, you need to divide both the numerator and the denominator by a number that goes into both the 6 and 15, and you have to try and find the biggest number that goes into 6 and 15. And the best way to do that is think of which times tables both 6 and 15 are in, and they're both in the 3 times tables. So if I count up by 3s, I go 3, 6, 9, 12, 15. And so 6 divided by 3 is 2, and 15 divided by 3 is 5. And so therefore, if we simplify 6 over 15, we get 2 over 5. If you could please complete this question over there to simplify 12 over 36. Now, once again, to simplify 12 over 36, we have to think of what number or which times tables do both 12 and 36 belong to. Now, sometimes when you simplify fractions like this, it might take you a few goes to get to the answer. If you're really good with your times tables, you'll be able to see that the answer to this straight away is 1/3, but some other people might have to divide it a few times because they may not see the answer straight away. So you might decide to start by just saying, well, I think I can divide them both by 2, and that's okay because they're both even. And 12 divided by 2 is 6, and 36 divided by 2 is 18. But then you might look at that and say, well, I think I can divide those both by 3 because I know that they're both in the 3 times tables, those numbers. So 6 divided by 3 is 2, and 18 divided by 3 is 6. But then you can say, well, I think I can divide them also both by 2, and you'll get 1 over 3. Now, obviously, that was the long way to do this question. I mean, at this stage, we probably could have divided by 6, and we could have. The other thing is, when we first look at the question, we could have just divided both the numerator and the denominator by 12. And that really would be the quickest way to do this question. Okay, sorry, that went over the page. I'll just fix it. So the quickest way would be to divide them both by 12. So 12 divided by 12 is 1. And 36 divided by 12 is 3. So look, no matter how you do the question, if you just keep simplifying, you will eventually get to the right answer. If you're very confident with your times tables, you can get to the answer in one step. Otherwise, sometimes it might take you a few steps, and there's nothing wrong with that. Okay, now in this question, where I'm asked which fraction is larger, 2/3 or 5/7, because the denominator of these two fractions are not equal, I need to write them both with the same or common denominator. So I have to think of a denominator that both 3 and 7 will go into, and that denominator would be 3 times 7, which is 21. So what I'm going to do is make the denominator of both the fractions 21. So I'm just going to rewrite the fractions so that they're both now out of 21. And if they're both out of 21, I can compare the numerators, okay? So again, this is equivalent fractions. So my denominator is going to be 21. So I say 3 times what is 21, and that's 3 times 7. So I have to multiply the numerator by 7. 2 times 7 is 14. Then I look at this second fraction and I say, how do I make 7 into 21? Well, I times it by 3. So I also times the numerator by 3, and 5 times 3 is 15. So then I look at my two answers and I see which one's bigger. I've got really that 2/3 is the same as 14 over 21, and 5 over 7 is 15 over 21. Now, obviously 15 out of 21 is bigger than 14 out of 21. So I can say that this is the bigger one. Now, the question was, what is bigger, 2/3 or 5/7? I know that 5/7, which is 15 over 21, is bigger. So my answer is, therefore, 5/7 is larger. So if you could please do this question over here, which is larger, 3/5 or 5/8. Okay, now our first step is to look at the common denominator of both those fractions. And we have to see what number both 5 and 8 go into, and you can just do 5 times 8 is 40. So both 5 and 8 will go into 40 because 5 times 8 is 40. Our next step is to write both fractions out again with a denominator of 40. So we say, how do we go from 5 to 40? Well, we times it by 8. So I must multiply 3 by 8. And 3 times 8 is 24. Then I look at my second fraction, 5 over 8. And how do I change the 8 into 40? I times it by 5. So I also times the numerator by 5. And I get that 5 times 5 is 25. So therefore 25 out of 40 is bigger than 24 out of 40. So this is the bigger one. So therefore I can say 5/8 is larger, because 5/8 is really 25 over 40. Now for the last question. And that question is, what fraction is 60 centimeters of 2 meters? So you just have to think you've got 2 meters, let's say 2 1-meter rulers, just like the teacher rulers. Pretend you've got 2 of those. Now what's 60 centimeters? That's like having 2 of your normal rulers, 2 of the 30 centimeter rulers. So we're trying to see what fraction 60 centimeters is of 2 meters. Now what we have to notice here is that both these units are not the same. So your first step is to make sure that both quantities have the same units. And because they don't, you need to change one of the units to make it smaller, to make it the same as the other. Now it's always easier to change big units to small units, because when we change big units to small units, we multiply. So what we're going to do, we're going to change 2 meters to centimeters. Now we know that 1 meter is 100 centimeters, and so 2 meters will be 200 centimeters. So therefore the question now becomes, what fraction is 60 centimeters of 200 centimeters? So we just write that fraction as 60 centimeters over 200 centimeters. And because the units are the same, once the units are the same, we can cross them off. And so what we're going to do, we now need to simplify this fraction. Okay, so 60 over 200. You can divide them both by 10. 60 divided by 10 is 6, and 200 divided by 10 is 20. When you've got whole numbers and you have a fraction with whole numbers and zeros on the end, you can just cross off a 0 from the top and the bottom, but only one from the top and the bottom, okay? Only one at a time. So now we need to simplify 6 over 20. Now because they're both even, you can divide them both by 2, okay? And 6 divided by 2 is 3, and 20 divided by 2 is 10. So therefore, 60 centimeters is 3/10 of 2 meters. So what fraction is 60 centimeters of 2 meters? It's 3/10 of 2 meters. Now you can pause the video and do this question over here. What fraction is 20 minutes of 3 hours? Now just notice that firstly the units are not the same, so we really need to change the hours into minutes. Now we know that 1 hour is 60 minutes, and so therefore 3 hours will be 60 times 3, which is 180 minutes. So now I can look at the question in a different way, and it can read, what fraction is 20 minutes of 180 minutes? And to write one fraction as a quantity of the other, you just put one fraction over the other fraction. So what fraction is 20 minutes of 180 minutes? So the units are the same, so I can cross them off. So 20 minutes over 180 minutes is 20 over 180. Notice they're both whole numbers and we've got zeros on the end of each, so we can cross the zero off from the numerator and the denominator, and that becomes 2 over 18. And notice that both 2 and 18 are even numbers, so we can divide them both by 2, and 2 divided by 2 is 1, and 18 divided by 2 is 9. Therefore, 20 minutes is 1/9 of 3 hours. And that's the end of this revision worksheet for fractions.